Welcome to our session on probability. In this session, we're going to look at one discrete probability function, which is called the discrete random variable. This is one probability that is easy under the distributions of probability. So we have four key probability distributions. There's what we call the binomial distribution. There's what we call the Poisson distribution. There's what is called the normal distribution. And there's also what we call the discrete random variables. So of these four distributions, the easiest one is the discrete random variables. So I'll look at a very easy example, then I'll take you through an exam type of a question, then I'll ask you to answer precisely using the procedures I'm going to use. To start with, an examiner will give you a table like this, where you're given the values of X and the respective probabilities. You need to ensure that the probability always adds up to 1. So you'll be asked to find the mean, the variance, standard deviation, and the probability that X is more than or greater than 4. So to tackle such a question, it's very easy to use a table. So you extract the information as follows. Values of X, we have 2, 4, 6, 8. The probabilities, we have 0.1, 0.3, 0.2, and 0.4. When you add the probabilities, they should give you 1. And the mean, which is also the expected value, is simply found by multiplying the values of X times the respective probabilities. So the mean, sometimes they'll ask you find EX. This is the same as the expected value. You're simply multiplying 2 times 0.1, which is 0.2, 4 times 0.3, which is 1.2, 6 times 0.2, which is 1.2, and 8 times 0.4, which is 3.2. The sum total is what we call the mean. So in this case, we're going to add this up. So we're going to get 8 here. And when we add this up, we're going to get 5. So you get your 3 marks by showing this computation. So our expected value or our mean is simply 5.8. If you're not using the table, you could still do the same. You show the working 2 times 0.1. You add 4 times 0.3 plus 6 times 0.2 plus 8 times 0.4. When we total this up, we get 5.8. This is what we call our expected value. Then we also have what is called the variance. The variance is simply, firstly, we square the values of X in here. So here we're going to have 2 times 2, we get a 4. 4 times 4, we get a 16. 6 times 6, we get a 36. 8 times 8, we get a 64. Now, according to this, we are going to multiply the X squared times the probability. So 4 times 0.1, which is 0.4. 16 times 0.3, what do we get? 16 times 0.3.
4.8.
4.8. 0.2 times 3.6, what do we get? Then 0.4 times 64, what do we get? What are we getting?
25.6.
So 5.6. And when you total them up, what are we getting here?
The 5 venues that was took with the promised statement and used this extensively too over the last 2 years, covering for international matches, Outlier, 38 venue.
38. So to find our variance, therefore, it is simply integration of x squared, x, which is 38, subtract the mean squared. So 5.8 squared, what are we getting?
Very seldom on home soil. There's feedback from Moses.
Moses, please make sure you. What are we getting?
Mr. Collins?
Yes, please.
I have a question. You know, when you're doing squared, right? Is there a shortcut like to do the same way you've said, like 5.8 38 minus 5.8 squared is like there squared on the calculator?
Yes, there is on the calculator.
Yes, where? I'm using the same scientific calculator.
The Casio or a
Kenko.
Okay, Kenko is under Casio.
Super. Yes.
So that's one other lesson we're going to have to learn how to use your calculators. So your Kenko will look like this here. So the square is there. 5.8 then squared then equals.
Okay. Right. All right. Okay.
What is giving you?
4.36.
4.36 as the final answer?
Yes.
So 4.36. Good. So this is called our variance. Then the standard deviation, when you square root the variance, it's called the standard deviation. So our standard deviation is the square root of this answer we found. 4.36. What are we getting? Square root looks like this here. So 4.36 square root, then you get the answer. What are we getting?
2.09.
2.09. Okay, so this is how we find our standard deviation. Then the last question was, what is the probability x is more than 4? So which numbers are more than 4 here? Probability x is more than 8. Which numbers are more than 4? The probability of x is equal to 6, yes, plus 6 and 8, isn't it? Probability x is equal to 8. So what's the probability of 6?
0.2.
And the probability of 8?
0.4.
So what is the total probability?
0.6.
0.6.
0.6. Okay. So that is how you're supposed to do that. Any questions so far? Anyone lost? Let's do it quick. Can you remember? How did we get, I'll call this column what? This is column 1, column 2, column 3, column 4, and column 5. So we are only given column 1 and column 2. Quickly, how did we get column 3? The ladies, column 3, we multiplied what?
Column 1 and 2.
Column 1 times column 2, good. Then the total is called what?
The mean.
A mean. How did we get column 4? We simply squared column 1.
We squared column 1.
Great. And how did we get column 5?
Multiplied column 4 by column 2.
Excellent, column 2. Then how did we get the variance?
Summation of column 5.
When we sum up column 5, the answer we get, yes?
Then squared the mean, column 3.
And we
Total,
square
yeah.
the mean to column 3.
And then subtracted.
And we subtracted.
Got the
Great.
variance.
All right. Then how did we get the standard deviation?
We square the variance.
We squared the variance. We square rooted or squared?
Square root of the variance. Square root the
Square root.
Yes. We square root our variance, yes. So after getting the variance, after square root, we now call it what? The standard deviation. So later on, we're asked to calculate the value of x is greater than 4. What did we do? X is greater than 4.
We add all the values that are greater than 4.
Add on the values that are greater than 4. Now suppose it says greater or equal to greater or equal to 4. Where would we have started from?
We start from 4.
4 itself, right? Okay, would have started from 4 itself. Excellent. So are we together, all of us? So now we're going to go to those who purchased the pamphlet, the questions and answers, page number 28. We're going to look at this exam question. Below shows a probability distribution for a random variable. We are asked to find the mean, the variance, and the standard deviation for this. Okay, they can add greater than 4. So I will give you just 5 minutes to try this question. And spin, grab it. Find. Okay. So to find the values of the mean, the shortcut for the mean is given by summation ex. This is different from the summation of x, because some people, when they are given e, they want to sum up this and they think this is the mean. This is the actual letter e. So this stands for the mean. So Moses and Kalonji, how do we find the mean? We multiply the values of x times their respective probabilities. So what are we getting here?
So there it's a 0.6, 3, 2.7.
Okay. And what is the total?
6.3.
6.3. Okay, great. The next team, Lottie, Mildred, and Nyako. How do we get the variance?
So you square the x values.
To get when you square the x values, what are we getting here? 9, 36,
36,
81. Then how do we get this column? Augustine, Chileshe, and Chuele. How do we get this column?
The value of x squared multiplied by the probabilities.
So here, what are we getting? One 1.8.
1.8.
18.0. And 4.3. And what do we get as our total? Is that so?
Isn't it 44?
Yeah, I'm getting 44.1.
4.1, okay.
Me too.
So after we get 44.1, what do we do? After we get 44.1, Gillian, Vanessa, and Kafula. What do we do? How do we get the variance?
We subtract the summation of x squared plus px minus the summation. Okay, so like for the values, we will subtract them 44 minus 1. 44.1 minus the summation of minus 6.3.
What do we get?
37.8.
7.8. Is that correct?
Yes.
It's 7.8. Are you agreeing?
Isn't it the square that I found that 9.69, isn't it?
Yes.
Extensively across Europe, looking
What 4.1 minus what? That's 7.8.
No, that's 9.69.
What's the final answer?
4.41. 4.41.
4.41. Okay. So this is for the variance. How do you find the standard deviation?
You square root the variance.
You square root the variance. So what do we get when we square root the variance?
2.1.
2.1. How do you find the probability x is greater than 4?
You add up the probability of 6 and 9.
Add up the probabilities of 6 and 9. Why?
Because those are the x values that are greater than 4.
Because those are the x values that are greater than 4. Excellent. So probability of 6 and 9. So what are the probability of 6 and 9?
0.50
Mm-hmm.
and 0.30,
Which is
0.80.
excellent. So let's verify the solutions. So if you're going to the pamphlet, check it. find that the solutions are in tandem with what you found. If you're not using the table, this is still correct. You do the array of these ones, 6.3. Is that what we found as our mean? See how you write the mean, you write this and that. And the variance is xpx minus the value of the mean. So we found 4.41 minus the 9.69, which is 4.41. And the standard deviation is when we square root our variance, which is 2.1. So this is precisely how you need to answer an exam question. So last year, the exam question that came in that line was this one here, which I'll send on the group. I'll need you to calculate it as homework. So it looks something like this: the proportion, calculating the mean, and the standard deviation. Okay. So hope this is clear. We can go to some other topic. We go to statistics and back to probability. Statistics. So we'll look at the assignment question, but let me give you my own simplified. We're given team A and team B. We asked that team A has the following: 2, 3, 3, 2, 4, 7. 6, 19, 20, and 5. Here we have 4, 3, 7, 2, 2, 9, 15, 3, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we are being asked to find all the measures of dispersion and central tendency. Find all measures of dispersion and central tendency. And identify the outliers. Find the measures of what? Central tendency and variation. And variation. And also, we are asked to draw the box whisker diagram. And also identify the outliers. So I'll do team A, you do team B. So the first thing you need to do is to rearrange your data in ascending order. So we have 2, 2, 3, 3, 4, 5, 7, 6, 7, 20. We have what? The values of X as 2, 2, 3, 3, 4. What else we have? 2, 2, 3, 3, 4, 5, 6, 7, 20. 2, 4, 4, 5, 6, 7, 20. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. Have I left out anything? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, there are 9. So we're being asked to find the measures of central tendency and dispersion. So firstly, let's square them. 2 squared is what? 4. 4, 9, 9, 16, 25, 86, 49, and 400. So quickly, the ladies are quicker. Get the totals, everyone. The totals. So the total of x is called the sum of x. We use this symbol. The total of x squared is called the sum of x squared. And also we find our sample. How many are they? They are 9. So let's add them up quickly. So the gents who are slower can add the x's. The ladies who are faster, they can add the x squared. So 2 plus 2 is 3.
So the sum of x is 52.
52? Not 51, it's 52.
I found 52, unless if I'm
Me
making
too.
the sum.
All right. Then x squared.
552.
5, 5, 2. Okay. So I'll give you the formulas and you give me the actual values. So we have what is called the mean. The mean is simply given by the symbol x bar. So this mean is summation of x divided by n. Then we also have what is called the variance, which is given by summation of x squared minus summation of x to the power 2 over n, everything over n minus 1. And the standard deviation, the symbol is simply an s. Here it is s squared for a sample. For a population, we use this symbol sigma squared. Here, for a sample, we use s, standard deviation. But for population, we use a sigma. So to find our standard deviation, we're going to square root the answer we're going to get for the variance. Then we go to our coefficient of variation, which is simply standard deviation over the mean times 100. Okay, so quickly, what are we getting on the mean? 52 over 9, what did we get? 2 over 9.
5.78.
3 decimal places.
5.7.
How many decimal places?
3.
5.778.
Okay. The variance. Five, 5, 2 minus 5, 2 squared over 9. Everything over 9 minus 1. So we start from here. 52 squared over 9. The answer is subtracted from 300. 300 minus 552 and divide by 8. 31 point what? 44. What are you getting?
$37.5.
37.5. What are you finding?
I'm finding 31.
31.44, isn't it?
Yeah,
31 point something. 31.5. Yeah, 31.4. Sorry.
Then when you square root it, what are we getting?
5.608.
5.608. And the coefficient of variation? We divide the standard deviation, 5.608, divided by the mean, which is 5.778 times 100. What are we getting?
I'm getting 97.06.
At 7.06%. Okay, this is one topic that most people underrate. Okay, I'll go back to probability after this. I want people who are in BID to also understand. By the way, BID stands for brought in dead, meaning you are really behind. We want you to put you at par with the rest.
Yes, please.
I have a question.
Yes, please.
In this particular method, when finding the mean, we did summation of x over a number of values. But in the previous example,
We're
when we
multiplying by the probability. So the question is, which formula do we use? It depends on what data has been given. So that is under probability. This is under statistics. So this is a formula for the mean under descriptive statistics.
All right, thank you.
So you discover that there are about 98 formulas you need to know before the exam. So you need to understand each piece of them. For the first test, at least we need to know about 25 formulas. I need them to be part of you.
So are these formulas given during the test or exam?
Yes, he gives this, but the previous lecturer never used to. So you're very much spoon-fed. So, but I would want in my class you understand them by heart. You are given though. Are we together? Any other questions?
I wanted to find out what value did we find for the variance?
The variance was that 1.44.
Okay, thank you.
Okay, can we proceed? All right, so we're given the values of x. Again, we had what? 3, 3, 4, 4, 5, 6, 7, and 20. We have 1, 2, 3, 4, 5, 6, 7, 8. Which number has been omitted? 2, 2, 3, 3, 4, 5. Okay. So 2, 2, 3, 3. We have 2, 2, 3, 3, 4, 5, 6. So there's anything. 2, 2, 3, 3, 4, 5, 6, 7, and 20. So although you're in BID, at least there should be something you know by now. So please, let's start with the measures of dispersion. The range. What is the range?
I can't agree more. I was in BIT.
The range? What is the range?
The highest minus the lowest.
The highest value minus the lowest value. And what is the highest value?
20.
The lowest value?
2.
So what becomes our range?
18.
18. Okay. Then the mode. What is a mode? Mode is what? The most frequent. Which one is the most frequent number here? One which appears the most?
2 and 3.
2 and what?
2 and 3. 2 and 3.
Correct. Then we go to the quartiles. We have the quartiles. There are 3 quartiles. We have Q1, the quarter. We have Q2.
Let me go my earphones on. I don't even know where they're.
Please mute yourselves, which is half, and we have Q3, which is 3 quarters. Now, the quartiles give you the quarters that are the percentiles. So the first quarter of n plus 1. So you need to first find n plus 1. Our n initially was what? 9. 9 plus 1 is going to be
10.
what? 10. So the first quarter, before we get to finding the first quarter, so the quarters give you the position. If you find an answer like 2.25, you get the nearest number, which is 2. If you get 2.5, you add the second number and the third number, you divide by 2. But if you get 2.75, you round off to the nearest number, which is 3. So here the first quarter will be a quarter of what? N plus 1. And since our n plus 1 is 10, what is a quarter of 10? What is a quarter of 10?
2.5.
2.5. So what does this 2.5 mean?
You round off. No?
No,
We add the
0.5.
two figures. You add 2 and 5, then divide by 2, then round off the answer to the nearest.
Great. If you have 2.5, you get the number which is here, plus the next number, you divide by 2. If you have 3.5, the third and the fourth, divide by 2. 100.5, the 100 and the 101 number, divide by 2. So here, our 0.5, so we get the second number. Which one is the second number? This number and this number. So we add the 2. So 2 plus 3 divided by what? By 2. So our final answer will be 2.5. 2.5 is actually our first quarter. Q1 means the lower quarter or the first quarter. Q2 means the second quarter or the median. So half of n plus 1. Our n plus 1 is what? 10. Half of 10 is what? 5. 5 is a position. So which one is our fifth position? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the fifth position is 4. So meaning 4 is our median or our second quarter. How do we find the third quarter? 3 quarters of n plus 1. So what is 3 quarters of 10?
7.5.
7.5. So what do we mean when we get 7.5? What do we do? 7th plus what? The 8th number. We divide by 2. So what's our 7th number? 6.
6.
And our 8th number? 7.
7.
So 6 plus 7 divided by 2, we get 6.5. So this 6.5 is called our upper quartile. A quick recap. This is what we call descriptive statistics under ungroup data. Q1, basically the range is simply the difference between the highest number and the smallest number. It was 20 minus 2. We get 18. Half of the range is called the mid-range, which will be half of 18, which is 9. The mode looks at the most frequent numbers. So if all of them were single numbers, we'll say there's no mode. We could have one predominant number, or 2, which is a bimodal frequency, or 3, which is a multimodal. So in this case, we had 2 and 3, which are appearing the most. So we call them the mode. Then we went to the quartiles, where we found our first quartile. Q1 is a quarter of n plus 1. So a quarter of 10 is 2.5. So we get the second and the third number divided by 2 to get 2.5. Our Q2 is half of 10, which is 5. So we went to the fifth number, which is 4. Our upper quartile, which is Q3, is 3/4 of n plus 1, which is 3/4 of 10, which is 7.5. So the 7th and the 8th, 6 plus 7 over 2, which is 6.5. So we now have the 5 summary key points. These summaries are important for the box whisker diagram. Number 1, the highest value is for the maximum value of x. What is the maximum value of x? 20. Number 2, the minimum value of x. What was the minimum value of x? 2. Number 3, our first quartile. Number 4, our second quartile.
Kindly mute.
And number 5, our third quartile. These ones are important to draw the box whisker diagram. So our first quartile was the second and third position, which gave us 2.5. So 2.5 was our first quartile. And our second quartile was the 5th position, which was 4. And finally, our third quartile, which was the 7th and the 8th position, which was 6.5. So after getting these 5 summary points, we draw what we call our number line. 0, 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, up to 20 if you want. Here we have -1, -2, etc. Just helps you plot. So our lowest value of x was at 2. You put your bar here at 2. And the highest value was at 20. Okay. Maybe my sketch needs to be redrawn so that I can accommodate everything. So I can use the table of, so here 0, 4, 8, 12, 16, 20, 24, and here I have -4. So the lowest value was at 2. So you can put your 2 here. Your bar is there. Our highest value is at what? 20. And that's value here. And I'll sketch. Let's draw this line here. Then my Q1 was 2.5. 2.5 is somewhere here. After 2, draw a box. My Q3 was at 6. 6 is somewhere here. So this is your box whisker diagram. So here we have what? 2 of 2.5. Here we have 6.5 Q3. Okay. The interquartile range was the difference. IQR, it's a range between the quartiles. The highest quartile minus the lower quartile. So Q3 minus Q1, the difference between these two. What was our Q3? 6.5. Our Q1, 2.5. When we subtract this, we get a 4. So this is what we call the interquartile range. I repeat, we have the normal range, which is simply the difference between the maximum number and the smallest number of x. We call this just the range. But the difference between the lower quartile and the upper quartile is called the interquartile range. Half of the interquartile range is called the semi-quartile range. Half of the interquartile range is called a semi-quartile deviation. So half of 4 is called a semi-quartile deviation, SQD. So I'm just interested in how to draw this box whisker diagram. So what did we do? We identified the minimum value of x, which is 2. We put our plot there, our line there. The maximum value of x, which is 20, we put our line there. We drew this. Then this small point here is our Q1. Q1, which was 2.5. This edge of the box here is our Q what? Q3, which was 6.5. Now the examiner would want you to identify the outlier. How do we find the outlier? From the lower quartile, we subtract 1.5 of the interquartile range. In the lower quartile, what do we do? So when we go to the interquartile range here, we multiply it times 1.5. By getting a 6. So this 6, you subtract it from the lower quartile, from this guy here, from the lower quartile. So 2.5 minus 6, what do we get? 2.5 minus 6, what do we get? Negative. What do we get?
Negative 3.5.
Negative 3.5, which is somewhere here. Then to the upper bound, you add Q3 plus 1.5 IQR. So on the 6.5, we add a 6. So to the 6.5, when we add a 6, it will take us to 12.5, somewhere here. So interquartile range gives you the range of acceptable numbers. Anything outside negative 3.5 to 12.5 is called an outlier. So when we go to our figures here, you'll discover that the numbers that are odd one out, the outlier here is 20 because it's falling out of the range. So the outlier helps you identify which numbers are out of order. I repeat, how do we draw the box whisker diagram? We went to the lower value here. If you don't want to sketch it, the lower value was what? 2.5. And the higher value was what? 20. Then we draw the box here. All right. The lowest value, sorry, was what? Yes, Tiwe. You have a question?
Sorry, yes, I have a question. I'm lost on how you got 1.5. I think I'm black behind.
Okay,
when calculating the outlier.
It's part of the formula. The 1.5 is part of the formula. So I'm re-explaining this. So get me careful, because I need you to really understand this. Once you're lost, it becomes a problem for me because this is coming in your test 1. All right.
Okay, thank you.
So I'm actually preempting. Ideally, I want you to know the assignments on your own. So this is the question that I want The part-timers have already answered this. Almost all of them have gotten it correct. Okay, I'm preempting this. So after everything we have done, you need to identify the 5 key important things. The lowest value was what? 2, and the highest value was 20. Our Q1 was 2.5. Our Q2 was what? 5. And our Q3 was what? 6.5. The difference between these two is called the interquartile range. Interquartile range was 6.5 minus 2.5 to get 4. Then we get the correction term. You multiply this times 1.5. It's part of the formula. 1.5 times the interquartile range. We get a 6. Now this 6, to this edge we add the 6, which will take us to 4.5. To this edge we subtract the 6, which will take us to negative 3.5. So these two have survived. It's within the range. But this 20 has not survived. It's outside the range. So we call this an outlier. Are we together?
Yes.
All right. So at that note, I will need you to, not this time because it take a lot of time, before 20 hours, or I'll need you to do this question. Question number 2, the BIDs. Your colleagues have already done it. The question, calculate the extreme values and the quartiles for each group. So the first thing you need to do, is there a question?
Yes, sir. I'm a
Yes.
little bit behind on the box and whisker. How you?
You're kind of low. You can speak up.
I'm a bit behind on the box and whisker diagram. I'm lost on how you are finding some of the values. If you can just go back to that slide.
Okay. This slide.
Yes. So on, I'm clear on the 2.5 because that, yes, that was our Q1. Our Q2 was 4.
Our
Q2 was 4.
Oh, okay.
Yes. And then our Q3 was 6.5.
All right. Okay. Yes. Yeah.
Yes. So now the other values that you've added them.
So how did we get the 4 here?
The 4 there, the interquartile range, we subtract the third quarter from the first quarter. Yes.
So that's the interquartile range, which is 44. Then how did we get the 6?
So for that one, we multiply the interquartile range by 1.5 as it's part of the formula.
Get 6. Then what do you do to the 6?
So now that's where I'm stuck.
To the upper bound here. So Q3, we add 1.5 IQR as part of the formula to identify the outlier. So ELA Polamo, the outlier. So to this outlier, 6.5, we add this 6, which took us to 12.5. So we discover that 29 Polamo, this one is an outlier. Then to the lower bound, which is Q1, we subtract 1.5 IQR. So from this 2.5, subtract 1, it will take us to negative 3.5. So meaning it too nice to survive it. So this 20 becomes an outlier.
Okay, thank you.
Is that clear?
It is. Thank you.
All right. So now, taking you back to the assignment, I need you to do this question. I don't want to spoon feed you. Only those that the list are already full, by the way, for those that have paid assignments. If your name is not on those 20, then you just need to understand from the classes, because I don't want people to have the same solutions. So this is the question I want you to try.
What did you just say about the assignment?
I'm saying the assignment that I mentioned in the group that I only give the first 20. All right. the first 16. In fact, I think the list is already defined to confirm with Lisa, because I don't want too many people to have the same copy. So I've made 4 copies which are a little bit differentiated. So I made this clear on the group. Okay. So any questions so far? So question number 2.
A question, sorry. When they ask for you to comment about the performance of the groups, what do they want? What is the difference between the two groups? Just in general, what do they want to know?
They want to identify the outlier in one of the groups, in short. And let me take you through quickly on that one. Question number 3 or question number 2. So we're given 2 teams, method 1 and method 2. So what we needed is to rearrange them first of all in order. So we found the lowest value was 50 and the highest value was 89. So when we subtract these two, that is the range. Not everything not everything that was calculated was being asked for. Then to find the median, what we do? Half of n plus 1. So when you count in order, suppose you find your median as 79. Okay. Then the lower quarter is n plus 1 or a quarter of n plus 1. You find the figures there. So this one, if you get a 0.5, you add the second number and the third number divided by 2, which was 72. The upper quarter is 3/4 of n plus 1. So when you divide that, you get 7.5. It means the 7th number and the 8th number you add and divide by 2, which is 83. So you do the same for method 2. You first rearrange them in increasing order and do the same. The smallest number is 61 and the highest number is 81. Then the lower quarter is a quarter of n plus 1. So if you get 2.75, this means you round off to the nearest whole number in this case. Don't do the 0.5. So if it's 2.75, so you get the third position. If you are 2.25, you get the second position. So here we're getting the third position because there's 7.5 there. The median is n plus 1 over 2, or half of n plus 1. It's the same thing. So we have 5.5, meaning the 5th number and the 6th number, we divide by 2. Please, I'm a little bit fast here because I've already taught you. I just want to preempt as you are doing the work, which is 73. The upper quarter is 3/4 of n plus 1. It gives you 8.25. So because 8.25, the nearest is what? The 8th number. Don't even do this. 8th number, which is the upper quarter. Then to find the box whisker diagram for method 1, you get the 5 important things: the lower quarter, the quarter 1, quarter 2, quarter 3, and the maximum value. For method 2, also they'll ask you to find the box whisker diagram. You show these 5 important points. Then you now comment. What are the differences between the two groups? For method 1, they're asking you to find the range. The range is 89 minus 50, which is that. Then this one, the range is 81 minus 61, which is that. So you comment on the range to say method 1 has a higher range than method 2. Or you use any of the other inferences, which I haven't talked about. Sometimes if the median is closer to this, you say it is skewed to the left. If the median is closer to this, so if the median is closer to the upper quarter, you say it is skewed to the right. If the median is closer to the left, you say it's skewed to the left. So I am done with that part.
Sorry, just a question on what you were just explaining. I've seen that for others, when calculating the first quartile, second or third, if you get a value like 2.5, you would add the second value and third, then divide by 2. But for others, you were rounding off.
I mentioned in the class to say when you get a 2.5, what does this mean? It means the second number and the third number. Divide by what?
Yeah.
By 2. If you get a 2.75, you round off to the nearest number, which is what? 3. If you get a 2.25, this to the nearest is what? 2. All right. This is the order. So
if I get 2.3,
even if you got 2.3, this is 2. As long as 0.5, it's either you add the 2 and divide by 2. But if you get more than 5, it's 3. Less than 5, it is 2. You are clear?
yes. Okay.
All right. So can I continue or we are tired now? I will
Continue.
probability is a daily thing that happens. A probability is simply a chance that an event will occur. We're going to talk about axioms of probability. So we'll start with conditional probability. So conditional probability, whenever you see a slash or the word given or the word if, just know that this is what? Conditional probability. A if B, B given A. So to expand this, this is called Bayes' theorem. Bayes' theorem. So you take your B down there and intersect A intersection B on top. When you cross multiply, you get the intersection. So 1 times A intersection B is A intersection B. A given B times B, it will take you back to the intersection. Similarly, if you have B given A, the A will come down there, then you're going to have B intersection A, or A intersection B, it's the same thing. So to follow this up, suppose you're given X given Y. How do we expand this? What comes down?
The Y comes down.
And what do we have on top?
Probability of X intersection Y.
Okay. So this is Bayes' theorem. Anyone lost on Bayes' theorem? Okay. Then we go to the union set. Probability of A union B is simply probability of A plus probability of B. You subtract the intersection of A and B. So how does a union look like? And how does the intersection look like? The word and means what? Intersect. So if you're given probability of A times probability of B, it means we're intersecting A and B. So this is going to give you the intersection of what? A and B. To intersect is to multiply. So what is common between the two of them is called the intersection. Any questions so far? Then we have set A and B. If there's nothing in common, this means they are mutually exclusive. We also have A, there are two conditions that you need to know. If A intersection B is 0, it means they're mutually exclusive events. They have nothing in common. If A given B is equal to A, means whatever is down does not affect the upper set. So it means A and B are independent. If you have B given A, if they're independent, this must be equal to what? B. If you have B given Z, it's still B. This means that the events are what? Independent. So independence occurs if and only if A given B is A or B given A is B. If we're using letters X given Y, how do I know X and Y are independent? It must be equal to what? For these two to be independent, X given Y must be equal to what?
X.
X, the top guy. How about Y given X must be equal to what?
Why?
Exactly. That's what it means to be independent. This does not affect the occurrence of the other. Okay, so let's look at an example. Probability of A, 0.1. Probability of B, 0.2. Probability of A given B, 0.5. How do you find the intersection? Probability of A intersection B can use two methods. Number one, if there is no condition of probability, since intersection is multiplying, we have just multiplied these two directly. But this overpowers that rule. That is theorem one. So you start with this guy here. A given B must multiply what? The same bottom guy. Don't multiply it with A. I said whenever these two are the same, you get an intersection. So A given B times B give you 0.5 times 0.3, which is 0.15. In case you forget this shortcut, just go back to Bayes' theory. Start with the condition that has been given. A given B, first thing is you take the bottom guy down. B will be here. Then on top we have A intersection B. Then you put in what you already given. A given B is 0.5. A intersection B is what we are looking for. But the probability of B is what? Probability of B is 0.3. So when you cross multiply, A intersection B will be 0.5 times 0.3, which is 0.15. All right. Then the union set formula is the most faithful formula. The union of A and B is simply the probability of A plus the probability of B minus the intersection of A and B. So our probability of A in this case is 0.1. Probability of B is 0.3, and the intersection is what we just calculated. This means that if your intersection is wrong, your union set is also wrong. So what we are getting here as A union B is when we add the probability of A, which is 0.1, and probability of B 0.3, and the intersection here 0.15. Okay, can somebody tell me what is the complement of A and the complement of B? What is the complement of A?
0.9.
0.9. How do you get 0.9?
1 minus the complement of A.
Good.
Sorry, one minus the probability of A.
Of A itself. So complement means what I don't have. If I have 10%, what I don't have is 90%. So what's the complement of B? 1 minus what? B itself.
0.3.
So which is 0. What?
7.
0.7. Any questions at this point? Please speak now or forever hold your peace. Just FYI. Your husbands are busy bragging that my wife is doing a master's. They don't know that you're in BID. Yes, Tiwe? That hand up?
Yes. Is there a scenario where we are asked to find, for example, A complement given B?
Yes. There is. That is theorem 2. That's the toughest of it. All right. So Now, since you mentioned it, let me teach you what theorem 2 is. So we're going to have A is equal to A intersection B plus A intersection B, but the complement is on the other letter, which is B. If we had B here, this will be A intersection B plus A intersection B, but the complement will be on the other letter, right? Which letter? A. In short, when you add these two, you pick the common letter. Which letter is common? It is A. If you add the two intersections, which letter is common in this case? B, because these A's are different. Therefore, if I'm going to have probability of A intersection D plus B intersection D, the total is a common letter. What is the common letter here? You pick the letter which is common, which is what? B. All right. So to follow up here, I will ask, how do we find this complement on B and the complement on A? So we go back to our question here. What was our intersection? We found 0.15. Our A 0.1 and our B 0.3. So our A 0.1, our B 0.3, and our A intersection B 0.15. We're being asked to find probability of A intersection B complement and B complement here. So using theorem 1 or theorem 2, sorry, we're now going to substitute. So what is our A? 0.1. Then here we're looking for complement on B. And what is our intersection? 0.15. Okay. 0.15. Then for this one here, so this one goes this side, it will subtract. You get 0.05 as our A complement intersection B. Similarly for here, of course, this question was not well done. You're not supposed to get a negative, but just for learning purposes, 0.5. Here, when you put our B as 0.3, then here we put our A intersection B complement that we're looking at. The complement is on what? A this time. So plus the intersection 0.15. When this one goes aside, it will go to subtract. So we're going to get 0.3 and then 0.15 is equal to A complement intersection B. So here, when you subtract, we get 0.15. Now comes your question. How do we find A complement intersection B? A complement intersection B. So how do we expand this? This will be, what comes down here is the probability of B. Then what do we put on top? A complement intersection what? Intersection B. So since we found it, A complement here as 0.15, we put it here. And we already have the probability of B as 0.3. Put it here. So this will give us 0.5. So with what I've explained so far, you are now ready to consider with me question 1 of the assignment. So please, what I've explained is on record. Don't embarrass me. Let's go to the assignment question. So we're given this question here to say there are what? There are two policies. There's what we call the home insurance and the car insurance policy. It's 7 of all customers have a home insurance. So probability of H is 87%. So put 0.87. Then we are also told that 96 of all customers have a car insurance. So probability of car is 96, 0.96. Then further, we are told that every customer or all the customers have at least one of the two types. So when we add C union H is equal to 1. So in the assignment, I've differentiated it. I've used others for X, others have used H and C, others have used A and B. I've made a key there. Let them look different. Those of you who are doing it on your own, you can use any others. Please, I need you to understand the concept, not to memorize the answers. Part A, find the probability that a customer does not have what? A car insurance. Gloria, what does it mean? What are they asking for? Part A, what are they asking for? The probability that a car does not have what? A car insurance. What are they asking for? Gloria? Yes, Tiwe. What are they asking?
Let me try. Bringing the complement of C.
Yes, they're asking us for the complement of C. Does not have a car insurance. So it is 1 minus the probability of what? Car insurance. So this is 1 minus 0.96, which gives you 0.04. Good. Chileshe, the next one, what's the probability that he has a car insurance and a home insurance? What are they asking for?
The probability of H intersection C.
Of what? Of H intersection C, yes.
Yes.
C intersection H, because and means what? Intersection.
It's a, yes.
So the formula for intersection is the opposite for the union. It's probability of C plus the probability of H minus the union of C and H. So intersection has 5 formulas. You need to know when to use which one. We don't have conditional probability so far here, so we use this one here. So the probability of C is 0.96. Probability of H is 0.87. The union set is 1. So what do we get here?
0.83.
0.83. All right. Then what's the probability that he has a home insurance given that he has a car insurance? So what are they asking for?
Probability of home H given C.
Home given C. Good. So how do we expand this? What comes down?
Probability of C.
And what do we have on top?
Probability of H intersection C.
And what is our intersection?
0.83.
And what is probability of C?
0.96.
And what do we get?
Point 86.
0. What?
86.
86. Great. Then part D, what is part D asking for? Does not have car insurance given he has a home insurance. What are they asking for?
Probability. Complement C. Given H.
Given H, yes. Does not have car. So complement of C, given he has home insurance. So how do we expand this? What comes
Probability. H.
Probability of H.
And on top, what we have?
Intersection.
Whenever you do see this is complement of what? It's we're dealing with theory. So if you see the complement is on C, just know that the subject of formula was the other letter. So meaning we're supposed to have what? Probability of H. What's the probability of H going to be? C intersection H plus what? C intersection what? H. But the complement will go on which letter now?
H.
No.
C.
On the other letter. If there's H there, the complement will be on C. I repeat, how do we know which of the two formulas to use? Because here we would alternatively think C is got what? The probability of C intersection H plus C intersection H. Then the complement will be on the other letter. They C there, the complement will be an H. So how do we know? So I said here, since I said does not have a car insurance. So if the complement is on C, the subject must be the other letter, which is H. That's why I directly went to picking this formula here. Is that clear?
Okay.
Any
Yes.
questions before I proceed so far? Any questions? We are clear. So now, what is the probability of H? 0.87, and that's the probability of the intersection of H and C, 0.83. So 0.87, 0.83. But here, we don't know this. So our probability of C complement intersection H will simply be subtracting 0.87 and a 0.83, which is 0.04. So this is the one that is needed here. So 0.04 over the probability of H, which is 0.87. What do we get? What are we getting? Quickly, just divide 0.04 over 0.87. What are we getting?
0.046.
Okay, so this is how that question is supposed to be answered.